So, hello, my colleagues, and I hope everyone is well. So, the question tonight is why am I making this video? Well, as you can clearly see, this is Microsoft Excel. And Microsoft Excel has a lot of built in functions, and many of them are finance, which you can see I circled it in red here. There's a thing called f of x. Okay? And I believe that when you click on that, hold on, I got to get this thing to click on that. When you click on that, I had a little malfunction there. Sorry about that. Okay, when you click on that, for the second time anyway, you can see all these functions come up. And you notice it's only bringing up the most recently used. But I'm going to say all, watch now, all, look at all these functions. And this is not just finance. This is a ton of stuff. Statistics, probability, math, all kinds of stuff. And of course, finance. Okay? So you can see them all. But I can sneak in on it, watch. And I can say, look right here, financial. And then it gives me all the financial functions. Okay? So it gives me the effective interest rate, bond duration, which we'll talk about as the semester goes on, probably, if we're lucky. And you name it, it has them. And of course, it's got all our favorites, which I'll go to. Payment, to get the payment on a, let's say on an annuity or on a bond, on a mortgage, right, or on a loan. You have that. And you have the present value, the famous present value. And let me go up. You see PV here, present value. See when you click on them, all that information comes in. And let me go up. And here's future value. Let me click on that. See future value? Now, when you click on them, let me go to rate. This way we can calculate the rate of a loan, right? Let's go to rate. That's another important one. Come on. There it is, rate. Returns the interest rate per period of a loan or an investment. For example, use 6 divided by 4 for quarterly payments at 6% APR. So those are the real time value of money ones that are important to us, okay? So let me go up to future value. Now watch what happens when I say OK. You see how it brings up this box here, right? So I highlighted these boxes in red. Now there's a lot of equations which we kind of looked at. Remember I showed you some equations? They were really cumbersome. So you don't have to worry about that. So for instance, let's assume that, whoops, I didn't want to do that, but hold on now. Let's assume you wanted to find the future value and the rate was, let's say, 6%. Now I write it like this. See how I put 6%? Instead of putting 0.06, I put 6% because it knows the percentage means divide by 100. See how nice it does the math right there? Right. Now if I put 6%, I'm going to do a simple one. In the bank, right, for 1 year, okay, and I put $100 in. Now I'm going to make this 100 minus 100 because the money came out of my pocket and I put it in the bank. Okay? And the question is, hold on. All right, I made a mistake. So instead of putting it there, I should have put it in the present value. So you put $100 out of your pocket, right? It comes out of your pocket in the present, which is today, and you put it in the bank for 1 year at 6%, right? And obviously you're going to have $106. You see that? Everyone see that? So if I say okay, see how I would put it there? Beautiful, isn't it? Now I can open that up again and let us do for 2 years. So now we're going to get some compounding going on, right? And you can see now, instead of having 112, we have 112.36. We picked up 36 cents extra, right? Because it compounded. All right? So it's 2 years interest, right? 2 years. All right, now this type function, the type is a value representing the timing of payment. Now this is for the payment. So we're not going to use this yet, but when we look at this for an annuity, now we use the same function when it's an annuity. An annuity is a constant stream of payments, right? And I'll talk about that later. I'm going to just do the simple stuff now, one payment, all right? But eventually we're going to do annuities, and it's going to be just payments, okay? And we'll do that, and then we'll see how the type function works. It really becomes an issue whether you put the money in the beginning, the payment in the beginning of each period or the end of each period. If the money goes in at the beginning of each period, obviously you're going to make more interest, right? That should kind of make sense to everybody at this point, all right? So this is a very simple use of future value. Now let's say that you get, let's say you get 6%, but the money's compounded every 2 months, right? Every 6 months, I'm sorry. So see, it's 6 month periods now, right? So it's 3 months every 6 months, right? So now you see here that here's the interest rate, right? And 2 is the total number of payment periods in the investment. So really what I should have done is made that 4 for 2 years. It's 4 6-month periods, right? Now you can see how it grew to 112.55. So remember, this is 3% every 6 months, but I said, okay, let's do it for 2 years. So there's 4 6-month periods. So if it was 3 years, this would be 6 6-month periods, right? And that would be 6 6-month periods. So it's growing, okay? So my $100, and the more periods I have, the more my money grows, right? Obviously, the longer you keep the money in the bank, the more it's going to grow. Remember, the number of periods is the total number of payment periods in the investment, okay? Total. So for 3 years, and if it's 6 months, it would be 6 periods. I hope everyone's clear on that. So I'm going to say okay and put that there. Now I'm going to go over here and we're going to do present value. Right? Remember, present value is, now you can find it by just typing PV. All right, and I say go, and here it is. Look, popped up right up on top. So PV, and the same thing holds. Now, I'll show you how we can go backwards. Let's say our future value, which we know over here, here's our future value, was 119.41, right? 119.41. So the question is, how much today would I have to put in the bank, right, to accumulate 119.41? So I believe we said it was 6%, and I divided it by 2. It's compounded every 6 months, right? And I said it was for 2 years. Oh, that may be 6 periods, right? That may have been 6. Let's try it. It may have been 6 periods. Yep, it was 6 periods. So if I put, how much do I have to put in the bank if I get 6% compounded every 6 months and it's in there for 3 years? If I want to accumulate 119.41. So see, here I am trying to accumulate 119.41. So the present value function says, well, put $100 in the bank. Disregard these extra digits here. Put $100 in the bank, and in 3 years, compounded every 6 months, you will have 119.41. So you see, we went backwards on that, okay? And that's really all it takes. And you don't have to worry about equations. Notice how it puts it in red, because what you had to do is take that money out of your pocket, right? And I'll click on f of x again. The money has to come out of your pocket to go into the bank, so it grows to this. Remember, money out of your pocket is negative. So look here, formula result, $100. So it disregarded those extra digits. All right, so that is, this is present value, right? And I'll say, okay. So there's present value. Notice how it's less than the future value. Remember, present value is always smaller than the future value, right? So I'll say, okay. And over here, this was, I believe, future value. And here we have just the opposite. The future value was greater than the present value I put in the bank, right? So that grew, okay? All right, so that's simple. The next time the next little mini lecture I give you on Microsoft Excel, we're going to do annuities, okay? We'll do annuities, annuity functions. And then, so when we do annuities, which are constant payments over a constant period of time, we'll start using the payment function, okay? And then when I get a chance, I have a software electronic calculator. I will bring it up, and we will start playing with my little financial calculator. I know you have one in my finance lab. So this is a real simple look at future value and present value in Excel. Okay, if you have any questions, as usual,